Okay guys, so this is going to be a video for lesson 6.1, day 1. We did this in class on Friday. We're going to be going back over the nth roots and rational exponents, which is the big thing you need for this whole unit. So remember, there are a couple questions we talked about. What is the nth root of a? If x of n equals a, what is x? These mean the same thing. We're finding what that nth root of a is still. N of what number multiplied together equals a? So x to the n, remember, is x times x times x, all the way until it's been multiplied by itself n times. We can write this like this one over here. We use that radical with our n to write the nth root of a. So for our first example, it says, rewrite the following question other ways, then answer the question. What is the third root of 64? We could write, well, if x is to the third power, and that equals 64, what is x? Another way we could say this is, well, what is that third root of 64? We could write it using that radical form. One last way we could do this that we talked about in class was, well, 3 of what number multiply equals 64. Well, if we think about this, 64, our answer is going to be 4 because, well, if I have a 4 cubed, remember that's the same as a 4 times 4 times 4. Well, when we do that, we get back out a 64. So that means our answer must be 4. Another way to write this would be the third root of 64 is equal to 4. So we have a couple examples down below I'm going to go through. For this first one, a, it says the fourth root of 256. Another way to think about this would be, okay, well, what is x if I have it to the fourth power and I need it equal 256? If you know your exponents, your thirds, and your fourths, you'll be able to say, well, that's going to be 4, because 4 to the fourth power is 256. So here this would just be equal to 4. For b, 125, I know that's going to be 5, and that's because I know that a 5 times a 5 times a 5 is 125. For our next two, they're written with a fraction in their exponent. So if you look up above, that was one other way we were able to write this, that 1 over n. Well, our n still works the same way. I would take that 2 and say, well, this is the second root of 16. We don't need the 2 there technically. This is just the square root of 16, which is 4. But don't forget your positive and negative here. Now for d, 8 to the 1/3. This is the same as a cubic root of 8. Well, I know that 2 cubed is 8, so that means the cubic root of 8 is going to be 2. There are 4 practice questions down below. If you haven't done them yet, I recommend trying those. Remember, I'm taking this for a grade. Now, on the next page, we have some rules that we're introducing here. When I have an nth root of a, my n can either be an even or an odd number. When it's even, we have the potential for some imaginary solutions. When they're odd, though, they will always have one real solution. They will never have any imaginary ones. So in our examples that we had done in class, for a, we had taken n equals 3 and a equals negative 216. We could rewrite that as a cubic root of negative 216. Well, 6 cubed is 216. But if I have a negative here, that means I need a negative here. If we look above it, it says 1 real nth root. Well, we have 1 real nth root here. For b, it says the fourth root of 81. Well, I know 9 times 9 would be 81, but I want a fourth root, not a square root. But 9 also has a square root, that's 3. So that means my answer here must be 3. Because if I have 2 3 squareds times each other, that's a 9 times 9, which is 81. But 3 squared times 3 squared is also written as 3 to the 4th power. Now, it says over here that if our a is greater than 0, we should have 2 real nth roots when our n is even. Well, our n here is even. So instead of just 3, it's also plus or minus 3. So anytime this value we see here is an even number, we'll have 2 solutions, the positive and the negative. You should complete the practice problems down below now.